Hello everyone, in this video we will be solving problem 1717 maximum score from removing substrings. The problem statement is we are given a string s with two integers x and y which represents the value of a, b and ba. We need to remove the substrings a, b and ba from the original string s in a way that will give us the maximum points. The points we earn is going to be based on the values of x and y. If we remove ab, we get x points, and if we remove BA, we get Y points. The value of X and Y can vary based on the test case, so we need to come up with a solution where it could handle both the cases when X is greater or Y is greater. In example number 1, we have multiple occurrences of AB and BA. The maximum point we can gain is to start by removing the BA at this position, which will give us 5 points. And after removing that, we'll be left with this substring. This time, we'll remove the AB at the last position, which will give us another 4 points. We repeat this cycle across the entire string to figure out if there are any occurrences of AB and BA in it and accordingly collect the maximum points. With all possible combinations, with this input, we can earn the maximum points of 19. I hope you are able to understand the problem statement as it is very straightforward. Now let's switch to whiteboard and discuss the solution. Between x and y, as y is greater than x in terms of the points value, it is natural we should try to get as many y points as possible. And as y is tied to the substring BA, we should start by identifying the occurrences of BA in the input string. Once we have verified that there are no more occurrences of BA in the input string, only then we should start looking for the values that will give us x points, that is AB. I hope this logic is straightforward and we'll base our solution based on this premise. Let's understand this with this example. If I simply start looking for the substring in the given string s without verifying which will give me the maximum points, I might start by looking for the characters AB in the string. As there are two occurrences of A and B in the input string, it will give me a total of 8 points, as X represents AB and the value is 4. And after removing all of the ABs from the string, I'll be left with BA. And this BA will help me earn another 5 points, giving me the total of 13. Is this the maximum points that I can earn with this string? Maybe. But to confirm, let's repeat the same cycle, but this time we'll start with BA instead. I have two occurrences of BA here, which will give me 5 points each. Total is 10, and the remaining string is AB. This will give me another 4 points. Adding 4 to the total will give me a total of 14 points, which is greater than the previous value. This proves that it is important to know which value is greater between x and y so that we can start looking for the corresponding substring in the string s. In the brute force approach, we'll be running multiple iterations across the string s to identify the occurrences of the substring AB and BA depending on which value is greater and replace it with empty string. And as we identify the occurrence of the substring, we'll be recording the points that we earned in a separate variable. And when we are sure there are no more occurrences of AB and BA in the string s, we can stop the iteration and return total as our output. In this approach, as we are running multiple iterations to make sure that there are no more occurrences of the substrings AB and BA in the input string s, the time complexity is going to be huge. So now let's discuss how we can optimize the solution. The challenging part here is to identify if there is a substring that we are looking for getting built after we remove a couple of characters from the string s. That is the whole reason why we had to run multiple iterations on the input string s after we remove couple of characters from the string. Let's try to address that problem. Let's say my pointer is pointing at a character which matches to the second element of my substring that I'm looking for, which is A. And during the iteration, I'm saving all of the values in a separate collection. If my pointer at pointing at A and the last character that was processed and saved into the collection was B, this tells me that I found a substring. The same can be said for the string AB where the pointer is pointing at B and the last value that was added is A. If the values are correct, then I can take the corresponding values X and Y and add it to my total. And if the values are not equal to the substring we are looking for, then we'll add the value that the pointer is pointing into the collection and continue with the loop. Let's do a small dry run to understand this approach better. As we want to do a lookup on the last element that was added to the collection during the processing, we need to use the data structure that gives us a stack-like ability. Let's start with I is equal to 0. As there are no elements in the stack, we cannot look for a substring, so I'll add the current value into the stack and increment my pointer. With I is equal to 1, it is pointing at D. As it doesn't match the second character of the substring we are looking for, there's no way we can find a substring in S, so I'll add D to my stack. To save time, let me go ahead and prefill some of the values into the stack. With I is equals to 6, my pointer is pointing at A. And this value matches to the second character of the substring, so the first criteria is met. Now I need to look at the last character that was pushed to my stack with the first character of the substring. Does it match? Yes, it does. So I found a combination, or I found a substring. Instead of adding A to my stack, I will remove B from my stack as I don't need them in my output. And as I'm removing these, I'll also take the corresponding value and add it to my total. Moving on with the iteration, I is equals to 7. The next character is A, which again matches to the second character of the substring we are looking for. And the first character matches to the last element in the stack. We found another substring that matches our criteria. So I will repeat the same cycle of not adding A to my stack and instead remove B from the stack and take the corresponding value and add it to my total, bringing my total up to 10. Similarly, we'll continue the iteration on the remaining characters in the string to look for the substring BA as its corresponding value is greater than the value for AB. Once the iteration is complete, we'll start another run on all of the characters that we have added to the stack to check for the occurrence of the character AB. The approach is going to be same, where my pointer will be pointing or looking for the character B, while I'll be comparing or looking for the character A in the last element of the stack. With this solution, our time complexity is O of n, where n is the number of characters in the input string, while the space complexity is also O of n, as we are using this stack-like collection to store all of the characters after replacing or removing the substrings. I hope you are able to understand the explanation. Let me show you how we can implement this solution using Java. In this Java implementation, I start by comparing the values of x and y. If x is greater than or equal to y, it means I should be looking for AB first before starting with BA. So in that case, I'm calling the process method, passing A as my first character and B as my second character. This process method will return me a string with the remaining characters after removing the substring AB and the score that we calculated. Using the string that I get, I'm calling the process method again, but this time I'm reversing the order of the first character to B and the second character to A. And after that, I'm adding the two scores and returning it as our output. If y is greater, then we go inside the else condition where I'm changing the order in which the process method is being called. First, we start by calling the process method with B as my first character and A as the second. The return string is then fed into the process method again, and this time I'm passing A as the first character and B as the second. The score of both of the calls is being added and then returned as the output. In this process method, I am using the string builder object as stack to record the characters. Then I am starting a for loop to iterate through all of the characters and checking if the length of the stack is greater than 0 and the last character that was added, is it equal to the first character that we are looking for, and the current character that the pointer is pointing, is it equal to the second character. If both of the criteria are met, then I am removing the last element from the stack and adding the value that is the score into this variable. If not, then I am appending C to the stack. After the entire loop is complete and we have iterated through all of the characters in the string, I am converting the string builder into string and returning string and score object. This code, when submitted on LeetCode, beats 74% of the submissions in terms of runtime and 54% in terms of memory. Thank you for watching this video. I hope you are able to understand the explanation. The details to access the source code is available in the description below. Feel free to check that out, and I will see you in the next one. Thank you.